Hello students, I'm back again with another video. Today we will discuss about electricity part 2 video. Part 1 I have already uploaded. Those who have not watched part 1, please go and watch it. So today in this video we will discuss about electric resistance and Ohm's law. Alright, so you can see on the screen we will discuss about circuit and circuit diagram. We will discuss about resistance and factors affecting resistance. We will discuss about Ohm's law, and we will also discuss about series and parallel combination. Alright students, so let us quickly start our class. So firstly we have to know what is a circuit diagram. From small classes we have been learning about circuit diagram, though in class 10 standard we will learn it more specifically, but the idea of circuit diagram we have been learning from our small class. Alright student, you can see this diagram. This kind of diagram we have been learning in our smaller classes, in class 6, class 7, class 8, class 9 also. So in this kind of circuit diagram we just draw a battery, we draw a wire, we draw a bulb. This is also correct idea of circuit diagram which we have been learning in our smaller classes. But in class 10 we will learn specifically, alright, we will learn this kind of diagram. So the definition of circuit diagram is a diagram which shows various electrical components connected in an electric circuit with the help of symbol is called a circuit diagram. That means we have to draw a diagram with the help of electric symbol. Alright. So over here we have drawn a battery. We have not drawn one. We have not drawn the symbol. So this was according to our lower classes. Okay, but in class 10, in place of battery we have to mention it with a symbol. So see here, this is a symbol for our battery, this is a symbol for our switch, this is an ammeter, this is a rheostat, this is a voltmeter, this is a resistor. That means in class 10 we have to know that a circuit diagram is a diagram which shows us the full circuit with the help of symbol. Alright, so switch, you know, ammeter. An ammeter is an instrument which helps to measure electric current, and a rheostat is an instrument which control the amount of current. Then we have voltmeter. Voltmeter is an instrument which measure potential difference, and it is always connected in parallel, and ammeter is always connected in series. Alright, so next we have to learn about resistance. So what is a resistance? Resistance is the opposition offered by the conductor. Opposition means what? Something which stops the flow of electron. We know that electricity is flow of electron. So if something is stopping the flow of electron, we call it resistance. Alright, the scientific definition is the opposition offered by a conductor to the flow of electron is called electric resistance. So we also have factors affecting resistance of a conductor. That means there are some factors which affect the resistance of a conductor. Number one, we can see on the screen, the resistance of a conductor is directly proportional to its length. Directly proportional to its length means what? If length is more, resistance will be more. That means a long wire will have more resistance than a short wire. Alright. Then next we have the resistance of a conductor is inversely proportional to the area of cross section. Area of cross section, I hope you understand, it is the area like this. In this pen you can see this is the area of cross section. That means a full diameter. So the resistance of a conductor is inversely proportional to the area of cross section. Inversely proportional, that means it will be opposite. If the area of cross section is big, resistance will be small. If the area of cross section is small, resistance will be big. Alright. Then next we have the resistance of a conductor depends upon the nature of the material of conductivity. That means it depends upon the resistivity. Some conductors have high resistivity, some conductors have less resistivity. So according to the conductor, it will give us the resistance. Alright. Then the last one we have the resistance of a conductor increase with temperature. If we increase the temperature of any conductor, the resistance will also increase. Alright student. So student, let us study now about Ohm's law. What is an Ohm's law? So all physical conditions remaining same, the current flowing through it is directly proportional to the potential difference across it, and that means all physical condition remaining same, the current which is flowing through any conductor is directly proportional to its potential difference. That means if current is increased, potential difference will also increase. I will show you mathematically. Please see here. So mathematically you can see here, that means potential difference is directly proportional to I according to the statements of Ohm's law. So V is equal to IR. When this proportional sign is converted to equal to sign in physics, there will be an introduction of constant. This R is a constant. So we call it what? A resistance, which we have already learned. Resistance is what? It is the opposition offered by the conductor. So therefore I is equal to V by R. This is the formula for Ohm's law. Alright. Graphically, representation of Ohm's law will always be straight line. Any conductor which follows Ohm's law will always have a straight line graphical representation. Alright student. Alright student, let us study our next topic, and our next topic is series combination. So what happens in a series combination? In a simple word, in series combination, the same current will flow throughout all the resistor. Alright, so definition is something like this: when a number of resistors are connected end to end such that the tail end of one resistor is connected to the initial end of the another resistor so as to form a closed circuit, then such a circuit is called a series circuit. Alright, please have a look at this figure. I will take a simple example. Suppose there is a light, a decorative light. This decorative light, you use it in your Diwali, in your Christmas or any kind of party, birthday party. So with different kind of color, some might be green, red, yellow or whatever. Alright, so in this case what happened? The same current is flowing through it. Alright, the same current is flowing through it. That means what? If one of the bulb get damaged, that means what? The current will be affected. The current will not pass through the other bulb. This is the only disadvantage of one series combination. I hope from this you got the idea of series combination. That means the same current will flow throughout the resistor. Alright student? Alright student, now since we have already learned about series combination, now next we have to study about parallel combination. Alright, so in parallel combination, in a simple word, I can say that a parallel combination is a combination in which the current gets splitted. That means the current will be divided. Not like in series combination, the same current will flow throughout the resistor, but in parallel combination, the current will be splitted. So when we see the definition, it will be something like this: when a number of resistors are connected in such a way that they have a common positive terminal and a common negative terminal, then the resistors are said to be connected in parallel circuit. So student, to understand this parallel combination better, I'll give you a very simple example. Suppose this is my room, or let me say this is my house. So there are different rooms in a house. Alright, so in every room there is a bulb. Alright, so suppose this is room A, this is room B. Suppose the bulb of room A get defected, so it is damaged. Do you think the other room will get affected? No. Why? Because in parallel combination, the current is splitted up. From our meter box, the current is splitted up into different rooms. That's why it will not get affected. But if it was in case of series combination, it will be affected. Why? Because the same current will flow through it. Alright student? Alright student, let us derive an expression for resistance in series. Okay, so let us consider three resistors R1, R2 and R3 be connected in series as shown in the figure. I'll draw a figure, you can see here. Suppose this is a figure. This is our source, plus minus, the current is going from here. This is R1, R2 and R3. Alright, so it will have potential difference of V1, V2 and V3, and total it will have V. Alright, so I can write here V equal to V1 plus V2 plus V3, equation 1. Alright, that means three resistors are there, R1, R2 and R3, whose potential difference are R1, V1, V2 and V3 respectively, and total potential difference is V. We have also I. Okay, so by Ohm's law, which I have already explained in this video, by Ohm's law we have what is the formula? I is equal to V by R, isn't it? We have already learned. So V equal to IR. Cross multiply, we got V equal to IR. You can write this as equation 2. Similarly, I can write for V1 equal to I R1. For this V1 I can find separately I R1. V2 will be equal to I R2. V3 equal to I R3. Now substitute value of V1, V2 and V3 in equation 1. So V equal to V1 plus V2 plus V3. V equal to V1. What is the value of V1? I R1. Plus what is the value of V2? I R2. Plus what is the value of V3? I R3. Alright. V equal to, you can take common. What is common here? I. That means in every place there is I. So R1 plus R2 plus R3. Alright. I'll continue here. So V equal to I, again R1 plus R2 plus R3. But from equation 2, you can see the equation 2 here. V equal to IR. So in place of D, we will write V equal to how much? IR equal to I R1 plus R2 plus R3. Then we can cancel I and I. So R equal to R1 plus R2 plus R3. So this will write equivalent resistance. So S for series. Alright. Similarly, student, we will derive an expression for resistance in parallel. Alright. So similarly, we will take here, let us consider 3 resistors R1, R2 and R3 be connected in parallel as shown in the figure, which I will draw now, such that current I flow through it with potential difference V. Alright. So I will draw a diagram here. Suppose a rough diagram so that it won't waste our time much. Plus minus, this is our resistor 1, R2, R3. Alright, so current is here I, then total we have V, and this current will split up into I1, I2 and I3. Like I said, because it is one parallel combination, so current will be split into I1, I2 and I3. Alright, so we can write I equal to I1 plus I2 plus I3. Equation 1. By Ohm's law, we have what we have? I is equal to V by R. Equation 2. Similarly, we can write I1 is equal to V by R1. I2 we can write V by R2, and I3 we can write V by R3. Alright, so substitute the value of I1, I2 and I3 in 1. So we can write this equation 1 again. I is equal to I1 plus I2 plus I3. So I equal to I1. What is the value of I1? V by R1. So I equal to I1. What is the value of I1? V by R1 plus what is the value of I2? V by R2. What is the value of I3? V by R3. Alright. Again I is equal to, what you can take common here? V is common. So 1 by R1 plus 1 by R2 plus 1 by R3. Alright. Again from equation 2, we have in equation 2 I is equal to V by R. So in place of I we can write V by R equal to V by 1 by R1 plus 1 by R2 plus 1 by R3. Right. So V and V cancel. 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is our derivation. You can write here P because it is equivalent resistance for parallel. Alright student. So student, that was all about today's video. I hope it was useful to all of you. Do subscribe it, share it, like and comment below if you have any problem in any topic. I will surely make a video for you all. Stay safe. Have a happy learning time.